Here we have our data, people's salaries for the small internet business. We're going to use Excel, so copy the table to a clipboard, and then in Excel you paste it. And then to find the mean, so the average of all this, you just type in equals average and then select the cells you want to average. And it'll add all those numbers up and divide by 10, give you the average of them. The median, you type in equals median, and again select the cells, and it finds the one in the middle, the median. When there's an even amount like this, it takes the 2 in the middle and it averages them, so you get 52.5. And then for the mode, just type in equals mode and select the cells you want, and it'll find the one that appears the most, and 55 happens 3 times, so that's the mode. So enter those answers in, and then for the rest of this problem, they're adjusting the salaries. So for this one, everybody gets a $2,500 raise. So you go into Excel, and you can just hit equals A1 plus 2.5. Since our salaries here are, this is 20 means 20,000, $2,500 would be 2.5. And then if you just drag that down, it'll add the 2.5 to every cell. It'll copy that pattern, so it'll do B1, or sorry, it'll do A2 plus 2.5, A3 plus 2.5, and so on. And then just start over again. So equals the average, and select your cells, and you'll have your new average. And do that for the median and the mode as well. Type in your new median and mode, and continue with that part of the problem. C says everybody gets a 5% of his or her original salary. So you could, for 5%, you just do equals A1 times 1.05. So they get a 5% increase. So they were at 100%, and then add 5% to that, and drag that down. You'd have everybody's new salary here, and then once again, you're going to do mean, median, and mode. So equals average for the mean, and then select your data, and so on. Median and mode. One option is for him to just keep all the data or all the extra money for himself, just add 25 to his salary. So then you'd have this, for that option, it's just going to look like this. And then he increases his salary by 25,000, so he goes to 105. And then do mean, median, and mode for that. So that's number 10. For number 11, we're looking at some sample data, and we're looking for the range, standard deviation, and variance. And these are supposed to measure how spread out the data is. The bigger the standard deviation is, the bigger the variance, the bigger the range, the more spread out the data is, and the smaller those numbers are, the more together, and all the numbers are going to be close to each other in the data. So we'll use StatCrunch for this one. You can also do Excel, but I want to show you both of them. So open in StatCrunch. So here's our data. If you just do, we want to do the stats on our column, and we only have that one column of data, and we want standard deviation, variance, and the range. And be sure to use these values here are for sample variance and sample standard deviation. There are some at the bottom, unadjusted variance, unadjusted standard deviation. That would be if you had the entire population of data, but the problem clearly says we have a sample, we're using a sample, so use the sample variance and sample standard deviation. When you hit compute, it's going to calculate all the numbers you want here. So your variance, your range, and your standard deviation. The range is the easiest to understand. It's just how far apart the largest number is from the smallest. So if you do 469 and subtract 211, those are 258 apart. That's the range. These have a more complex way of computing them, but I really just want to make sure you understand it's a measure of how spread out the data is. So the bigger the standard deviation, the more spread out it is. And these are related. If you square this standard deviation, so take this number and multiply it by itself, you get the variance. This number multiplied by itself would equal 13,065. So they're really kind of very close related, the calculations you do to get them, because one's just the square root of the other, and this number squared equals that number. But that's number 11. Number 12, you can use stack crunch just like a number 11. You're looking for the sample variance and sample standard deviation. So you just don't have to find the range, but it's just like number 11. Here we're looking for a population variance and population standard deviation. So just remember, I mentioned this on number 11, but when you're selecting what you want, make sure you do the unadjusted variance and unadjusted standard deviation, because those are for the population. They're not adjusted for a sample. They calculate the variance and standard deviation for the entire population. And so that's number 14 is great to make sure you understand that standard deviation is measuring how spread out the data is. So this histogram, the blue shaded in area, the majority of it is pretty clumped together in the middle. There is some on the ends, but it's small bars on the end, not very much data on the end. Most of it is clumped and close together. So it's going to have a smaller standard deviation than this histogram because there's more data that's spread out. The bars on the end are higher in comparison to this, and there's just not as much clumped close together in the middle. So histogram B has a higher standard deviation because the data is more dispersed, more spread out. That's number 14. Number 15, we're doing a weighted average based on Clarissa's grades. So you make a little table of it in Excel to help keep track. Her courses, how many hours they're worth, and then I just summed up how many total hours she has. The problem tells you what grade she gets and how many grade points. An A's worth 4, a B's worth 3, and so on, and F's worth 0. And so what you want to do is calculate the total here. So if you have a 3-hour course and you get an A, which is worth 4 points, you want to do 3 times 4. So you get credit for each of those hours for a total of 12. So 3 times 4, I'd multiply and get 12. If you have a 3-hour course and you get a B's worth 3 points. So multiply again, you get 9. If you have a 1-hour course and you get an F, you're going to do in 1 times 0. That's 0 towards your total. So then sum all that up. You have a total of 30 points and 10 credit hours. So you just do 30 divided by 10, and you get 3. A 3.0 is her grade point average, and that's number 15. Here we're calculating a grade when it's broken down into percentages. So attendance is worth, let's pull this up in Excel, I've copied it over. Attendance is worth 20%, quizzes 20%, exams 45%, and the final 15%. And I wrote those all as decimals. And then just to prove that they should add up to 100%, I added them, and they did add up to 1. So Marissa, what she scored in each category, I wrote that down. And since she scored, so I'm doing multiplication here, since she scored 100% in attendance, she's going to get all 20% there. When you do 20% times the 1 for 100, you get 0.2. Since she only scored 89% in quizzes, she doesn't get the full 20%. She only gets, this is 17.8%. So you multiply these two together, and you get her score there for quizzes. So multiply each of them together. For exam, she gets that. Multiply for the final, and then add those up, and you'll see her grade in the class. And as a percentage, that's 86.85%. Slide the decimal over 2. And that's number 6. For this data, we're going to find the quartiles and some information in parts B and C as well. But start just opening it up in Stack Crunch. And we're going to do a summary stat on our column. And so that's the column we have. And then for they're listed right here. So Q1 and then Q2 is the very middle of the data. The second quartile is the middle of the data. And then Q3 would be for the middle of the top half of the data. So if you want to find those, you just select those. You can also hold down Control, and it'll find the interquartile range for you. So hit Compute, and you get your Q1, Q2, and Q3. And remember, the interquartile range is just the difference, the subtraction between Q3 and Q1. So you could figure that out manually. Just take that minus that. But there they are. So our interquartile range is 2.925, and we're going to use that to find the lower and upper fence. And I've done the computations here in Excel, but you can just use a calculator if you want. You take that interquartile range and multiply it by 1.5, and you get this value here, 4.3875. And we're going to use that to find the lower and upper fence. So you look at the first quartile and subtract that value. We're going to try to find the even lower number. And here's the lower fence. When you take first quartile and subtract that value we computed. And then take the third quartile and add the number, because we're trying to find an even bigger value. And so you get this. So our upper fence is here, our lower fence is here. Anything outside of that data range will be an outlier. So if you look at our data, there's nothing that's outside of our lower fence, lower than that. There's nothing outside of our upper fence, nothing bigger than that. So there are no outliers. All the values are between the lower and upper fence. So that's 17. Here we have those box and whisker plots with the quartiles. So what's the median value of X? You just look at X. The median value is right in the middle of the box, that second quartile, and it looks like it's at 40. The third quartile of Y, so you have in the box the first, the second, the third, and it looks like it's just above 50, so 52. Which has more dispersion? Which is spread out more? Well, look at Y. So the quartiles between 1 and 3 is spread out more, but then also all the extra data is really spread out as well. You see how long these lines are coming out. The bottom 25% and the top 25% are both really spread out. So Y definitely has more dispersion. Describe the shape of X. It's pretty symmetric. The quartile 2 looks like it's right in the middle, and then the whiskers come out the same length on each side, so it's symmetric. And then the shape of Y, and it looks like it's skewed to the right, which just means there's more data that trails off to the right as compared to the left. So this whisker here extends a lot farther right than we have the whisker extending left, so we say the data is skewed to the right. 19, we have data, and it wants the 5-number summary. So it's looking for, the 5 numbers are the minimum and the maximum are the first and the last, and then Q1, Q2, and Q3. So again, open that in StatCrunch. And then like we've done previously, go through stat, summary stat on the column, and the ones you want to select are the minimum, Q1, Q2 is the median, Q3, and then the max. And you get your 5-number summary here. So type that in. And then you're looking for the box plot that displays this. So the smallest end of the whisker here should be on 43. The top end should be on 67. C is the one that's going to have it perfect here. This line should be on 46. The middle one's 51. And then this one is on 56. And so C matches up to those 5 numbers, so C is the correct choice. And then it's skewed right here because once again the whisker goes a lot farther off to the right than it does to the left. For number 20, you want to do the same thing we just did for 19. Find that 5-number summary and then see which box plot lines up with the minimum value, the maximum value, and then Q1, Q2, and Q3 based on that 5-number summary you get from StatCrunch. So do it in StatCrunch again. And then is it symmetric or not? Well, since the 5-number summary comes out that it looks like this, yeah, that's symmetric. The box has a line right down the middle, and then both whiskers are pretty much the same length. So that's symmetric. Unlike this one, we'd say is skewed left, and this one we'd say is skewed to the right.